Okay, taking a look here at problem number 1. My table in the back, please make sure you're quiet. Shh, Richard. All right, so here for problem number 1, we're identifying our x and y intercepts. Remember the intercepts, if it's the y intercept is always going to cross over the y-axis. The x-intercept, which I think I did in blue. Do I have my blue highlighter? Yes, I do. My x-intercept, I always cross over the x-axis. In a situation right here, for our x-intercept, it's crossing over at the point 2, 0. And then our y-intercept is crossing over at the point 0, negative 2. Okay, for problem number 2, your x-intercept is crossing over at 2, 0, just like the first one. And then your y-intercept is crossing over at 0, positive 2. For problem number 3, your x-intercept is going over into the negatives, so it's negative 1, 0. Your y-intercept is also all the way down here at negative 5, so your y-intercept is at 0, negative 5. For problem number 4, x-intercept crosses over at negative 3, 0. And then the y-intercept is crossing over at 0, positive 2. Okay, so identifying the x and y intercepts when given the graph. It's very, very quick, very simple. Problems number 1 and 6, I told you guys to go ahead and skip. We're not going to worry about those. For problem number 2, to solve for the x-intercept, we would just divide 2 by 2 and 12 by 2. We would get that the x-intercept is going to be at a positive 6, 0, which is going to be located somewhere around here, off of the grid a little bit. And then our y-intercept means that we're going to divide everything by 3, so we would get 0, 4. And that's going to be located right here. And then we can, of course, connect them to create the line. I'm not going to take out my ruler right now because I just don't feel like it. So I'm going to draw it as straight as I can. For problem number 3, for our x-intercept, we're going to go ahead and divide by the 6. That's going to give us 2, 0. For our y-intercept, we're going to go ahead and divide everything by 4. That's going to give us 0, 3. So we're posting it up here. And again, connecting. Okay, for problem number 4, again, yes, I know we can't finish this off because it's going to be too large, but at least you can go ahead and do your intercepts. So for our x-intercept, you're going to have that being at negative 2, 0. And then your y-intercept is at 0, negative 8 for problem number 4. Problem number 5, for our x-intercept, when we divide by 5, we're going to get negative 2, 0. And then for our y-intercept, when we divide by a negative 2, we're going to get 0, positive 5. And this is what your graph should look like. Okay? Again, if I had my straight edge, it would be much straighter than what we've got graphed here. All right, so that's just kind of reviewing over what we have already done for the past couple of days, your x and y intercepts. Very, very easy concept. We're going to get into a new concept today. So we learned about slope-intercept form, y equals mx plus b. We've learned about standard form, which is the ax plus or minus by is equal to c. Now we're going to get into a new form called point-slope form. All right, so here is what point slope looks like, and what our learning target for today is, and make sure you're turned around and facing the board. Richard, Sophia, make sure you guys are turned around and facing. I know it's hard sitting there because of where the angle is, but just make sure you're facing it. So our learning target for today is we can write equations using the point slope form, and you can identify special equations that have an undefined or a zero slope. So those are very, very special characteristics here. But this is our final form. We've got the point slope form that says y minus y1 is equal to m times x minus x1. Now we already know what m stands for based off of our slope-intercept form. We're already fully aware of the fact that m is going to stand for the slope of the equation. But in this situation here, our y1 and our x1, they're going to be representing a point that exists on this function. Whether you're looking at it as a graph already and you're trying to create the equation from point slope form, or if they give you a point and you have to create an equation. Now, a lot of times we don't keep things written in point slope form. We do eventually go ahead and rewrite so that way it's in slope intercept form. But it's a good idea to know point slope form, because there are some instances, some word problems or contextual problems, when writing it automatically in point slope form is the best for you, or writing it in standard form might be the best, or writing it in slope intercept form might be the best. And we're going to talk about the 3 forms and when to write in which form probably on Monday, either Friday or Monday. One thing I do want to make sure that you are very much aware, be mindful of negative coordinates. Because of the fact that we have a subtraction inside of this equation, a lot of times people drop their negatives by accident. So this is something you want to make sure that you are very careful about. Be mindful of those negative coordinates, because when you're subtracting, it's going to look like it's a negative already. You want to be careful about that, to not drop your negatives. So here we have our very first example. We've got a point, 2, 6, and a slope, 3/2, that's being provided for us. And we want to go ahead and first write the equation in its point slope form. And then from there, we're going to convert into slope intercept form, because that's our most common form that we're used to. So easiest thing to do, identifying that slope. Our slope is 3/2. We're going to identify our x coordinate, or what our x1 value would be. Our x1 value happens to be a 2. And that our y1 value happens to be the 6. Okay, and then I'm just going to place these into my actual equation. Again, I do apologize, I don't have a black anymore. My black ran out. But the equation is y minus the y1 is equal to my slope m times the entire quantity of x minus my x1. Ooh, where's my blue? There it is. Okay, so I'm just going to replace the information that I happen to know. I happen to know that the y1's value is a 6. I happen to know that the m value is a 3/2. And I happen to know my x1's value is a 2. And so then I just write everything in. I have y minus 6 is equal to 3/2 times x minus 2. And that's my point slope form. Okay, from here, now that I have the point slope form written, I can go ahead and start converting it by simplifying. Remember, to convert and get into slope intercept form, that's just that y equals mx plus b. I want to get that y isolated. So right now I have y minus 6 is equal to 3/2 times x minus 2. The first thing that I'm going to want to go ahead and do is that distributive property. We always want to get rid of our distributive property first. So that 3/2 can get multiplied to the x. It can also get multiplied to that -2 that we have here. So we're doing 3/2 times x. We're also doing 3/2 times -2. Okay, once we've done that, we now have 3/2x minus 3. Because 3/2 times -2 gives us a 3, or -3. Okay, now we still have this y minus 6 on the other side. So y is currently not isolated yet. We still need to continue getting that y isolated. So what do I have to do to get y by itself? Richard? Plus 6. So we're going to add 6. Now, where am I going to add 6 to? Am I going to add it to the 3/2 x? Am I going to add it to the -3? Am I adding it to both? Henry? Just to the -3. Remember, when adding or subtracting, you only do it to one term. When multiplying or dividing, you do it to all terms. Okay, so we're just adding the 6 to a like term. So this -6 is going to get canceled out by this +6. So y is now isolated. the 3 over 2x, and then negative 3 plus 6 comes out to a positive 3. And there's our final answer. Okay? So, yeah.
Get you just put an x for the y is equal to 3 over 2x. And can you just sub in the points and sub in the 2 for the x and then 2 and 6 for the y?
So, yes, 100% it will be. Until they ask you, what is the point slope form? So, the question's not always going to be, so what Hassan was asking, he says, wouldn't it be easier to just substitute our point into the formula and just go, okay, well, this is 6 equals 3 over 2 times 2 plus b, and then you could find your y-intercept. That, I showed you guys that method, and yes, that is easier for some. For others, people struggled with that process, and this might become the thing that's a little bit easier for them, is doing point slope form first. However, the problem is that the questions might ask you, what is the point slope form? So if they ask you directly, what is point slope form, you have to know what point slope form looks like in order to compose that. Okay? If they are directly saying that they just want slope intercept form, that's when you decide which one's easiest for you to do. Okay? But for right now, we're going to go through, figure out how to write in point slope form so that we can cover that skill. Okay? I want you guys to go ahead and try problem 2 and problem 3 on your own. For problem number 2, negative 2 is your x1 value, positive 3 is your y1 value, your slope was a 4, so we write it as y minus the 3 is equal to 4, your slope 4, times x minus negative 2. So again, the formula is y minus your y1 equals your slope m times x minus your x1. So you're just substituting your y1 value in, your slope value in, and your x1 value in. Now notice we have minus and a negative. When we have minus and a negative, that actually resorts to a plus sign instead. So I just rewrote it as y minus 3 equals 4 times x plus 2. Now I'm going to come on over here and I'm going to go ahead and do my conversion. So y minus the 3 is equal to 4 times x plus 2. I'm going to go ahead and do my distributive property first. So that means I'm doing 4 times the x, and I'm doing 4 times the 2. 4 times the x is going to come out to 4x. 4 times 2 comes out to a positive 8. So we now have y minus 3 is equal to 4x plus 8. Our last step is to add 3 to both sides. And your final answer is y equals 4x plus 11. 4x plus the 11. Okay? For problem number 3, again, your x1 value is a negative 1, your y1 value is a positive 2, your slope is a negative 1/2. So we have y minus my y1 becomes y minus 2 equals m, my m is a negative 1/2, times x minus x1 is x minus negative 1. You're just substituting those values in. You're replacing your x1, your y1, and your slope. But remember, a double negative actually results in a positive. So you have y minus 2 is equal to negative 1/2 times the quantity x plus 1. Okay, then we can take that value or that equation and we can go ahead and simplify it so that we get it into slope-intercept form. Okay, first thing that I'm going to do is distribute. I'm going to multiply. I get negative 1/2 times x and negative 1/2 times 1. Negative 1/2 times x is a negative 1/2 x. Negative 1/2 times 1 just comes out to negative 1/2, so minus 1/2. And then you get y minus 2 is equal to negative 1/2 x minus 1/2. Last thing that we want to do is add 2 to both sides. Okay, and that gives you your final answer, which is y equals negative 1/2 x, and then a negative 1/2 plus 2 is going to come out to a positive 3/2. David, off the computer. Okay, so So that's what it is when we're going from slope-intercept or point-slope form to slope-intercept form. Now, on the next page, if you flip it on over to the back, they're not going to give you the slope, but they are going to give you 2 points. They're going to give you 2 points, so that means you have to find the slope first before you can do your point-slope form. Remember the slope formula. Not one. So it's y2 minus y1 over x2 minus x1. Yeah. So our slope formula, write this up at the top. When finding slope, you are subtracting your y's. So you're doing y2 minus y1 on the top. On the bottom, you're doing x2 minus x1. Okay, the points have to correspond. If you write the y2 first, you have to write the x2 first. Okay, that point, both its values have to go first, and then the other point values have to go second. Okay, that's going to simplify it. Again, the reason it's y2 minus y1 on top is because that represents your rise. Your y goes up and down. Your x is your run, so that's why it goes on the bottom, rise over run. Okay, so looking here, the first thing that I want to do is I want to use these points, and I want to find my slope. So m, in this case, is going to be equal to the difference of my y's. So I'm going to do 9 minus 1 on the top. 9 minus 1 on the top. For my x's, I'm going to do negative 2 minus 8 on the bottom. Okay? This is my x1, y1. This is my x2, y2. What's 9 minus 1? 8. What's negative 2 minus 8? Negative 10. So we get 8 over negative 10. 8 over negative 10 simplifies to negative 4/5. So there's our slope. Our slope is negative 4/5. Now, just as I stated, I identified this as my x1, y1. It doesn't matter though. I could pick either point. Point slope means that you pick a point that's on the line and you use its slope. It does not matter which point you decide to pick. Now, we're just going to put these into point slope form. I'm not going to worry about rewriting right now. I'm just going to go ahead and write these into point slope form. So I'm going to do y minus, and that's going to be my y1 value. So I can do minus the 1. Here's my y1. Equals my slope, which is my negative 4/5, times x minus, and then whatever my x1 value is. What was my x1? What was my x value? 8. So my x1 value was an 8. There's my equation. Y minus 1 is equal to negative 4/5 times x minus 8. That's it. You're just substituting it into that formula that y minus y1 equals m times x minus x1. Okay? The most difficult part here is just you happen to find your slope. That's the hardest part. Now, for those of you who want to know what does this look like in slope-intercept form, if you want to try working it out yourself, I'll just give you what the answer would be, and then you can check it out to see if you can get it to the same result. But it would be y is equal to negative 4/5 x plus 37 over 5. That would be your slope-intercept form. But we don't have time to do that right now. Let's take a look at example number 5. Again, I'm given 2 points. I have to solve for the slope. I have to plug my slope formula. This is my slope formula. I have to subtract my y's and subtract my x's. Does it matter which point I choose to be my first and which one's my second? Does it matter? No, it does not matter. So, Jeremiah, tell me what my y values are. Okay? Negative 8 and negative 12. So I can do negative 8 minus negative 12, or I could do negative 12 minus negative 8. It does not matter. I'm going to just go ahead and do negative 8 minus negative 12. Yes? Yeah, we're going to get into that. I'm just writing it down right now. Okay? My x values is negative 2 and negative 5. What order do I have to write my subtraction for the x values? Based off of how I wrote my y subtraction, what order do I have to write the x's subtraction? Negative 2 minus negative 5. Good. Because I wrote negative 8 first, I have to write the negative 2 first. Those points correspond. They are the same point. They have to be the one that I wrote first. Now, if I did negative 12 minus negative 8, then I would do negative 5 minus negative 2. The order that you write your x is determined based off of the order that you wrote your y. So we're going to do negative 2 minus negative 5. Okay? Then we're just going to subtract. So negative 8 minus a negative 12, that's going to come out to a positive what? Negative 8 minus a negative 12 comes out to a positive 4. Okay? Negative 2 minus a negative 5 comes out to a positive 3. So we get 4/3 as our slope. Again, we're just going to write it into our equation. Remember, our equation is y minus my y1 equals my slope m times x minus my x1. Okay? So this y minus is not going to change. It's going to stay y minus. Okay, pick a point. Do you want the first one or the second one? Number 2? Okay, we're going to pick this point. This is going to be the point that I'm going to use. So I'm going to do y minus my negative 12 equals my slope, 4/3, times x minus, and then my x coordinate, negative 5. Now again, I've got those double negatives. I don't like having these double negatives here and here, so I'm going to rewrite them as a positive. So my equation is y plus 12 equals 4/3 times x plus 5. Those of you who want to identify the slope-intercept form, our slope-intercept form would just be y is equal to 4/3 x minus 16/3. Okay? If you have a table format, if you are given a table format, you have the same idea. Find your slope. Find your change of your y's over your change of your x's to identify your slope, and then you just pick one of the points and plug it into slope-intercept form, or a point-slope form. Okay? My y, I'm going from 14 to 8. That means I'm subtracting 6. Okay? I'm going from 8 to negative 7. I'm subtracting 15. I'm going from negative 7 to a negative 13. I'm subtracting 6. It's okay as long as it's proportional to what changes of x are. For here, I'm going from negative 4 to negative 2. I'm increasing by 2. I'm going from negative 2 to a positive 3. I'm increasing by 5. And here I'm going from 3 to 5. I'm increasing by 2. No matter how I set this up for my slope, I could write it as a negative 6 or a negative 15 on the top, which means I'd have a positive 2 or a positive 5 on the bottom. They both simplify to the same value, which is negative 3. So there's my slope. My slope of my table is negative 3. Now I just pick one of the points. I can pick the first, the second, the third, the fourth. It doesn't matter which point I pick. It does not matter which point I pick. They're all going to come out to the same value. Okay? That was a close one. I'm going to go ahead and just stick with the first point. When in doubt, always go with the first point. So we're going to have y minus my y1, which is 14, equals my slope, -3, times the quantity of x minus my x1, which is -4. If I were to convert this into slope-intercept form, it's going to be the same slope-intercept form for the table as well. Okay, y minus 14 is equal to -3 times x plus 4. That would be the most simplified version of it. We're going to skip number 7 just because I need to get you guys moving on. We'll skip number 8 as well. Let's go on to the last page because I want to talk about those special situations. Okay, so for our special situations that we have here, lines with undefined slopes and lines with 0 slope. Remember, if we're talking about a line that has an undefined slope, then what we're creating is a vertical line. We're creating a vertical line where your x is at a specific point, but your y is at an infinite number of points. So in this situation, when you're creating these undefined slopes, your equation is x is equal to whatever your x1 value is. Your x is equal to x1 because we don't have a specific value for y because y is everything. Y is every value that's positive, every value that's negative, and 0. It's an infinite range of values. So that's why we have it as an equation x equals instead of y equals. So for example, problem number 1, my x coordinate is a 5. So if I know that my slope is undefined, then my equation is just x equals 5. Again, this is only true for undefined slopes. This is only true for undefined slopes. Okay, for problem number 2, x is going to equal -6. That's my equation. That's it. It's that simple. If they tell you the slope is undefined, your equation is x equals and whatever your x coordinate is. So guys, what's the equation for number 3? X equals 4. What's the equation for number 4? X equals -5. It's that simple for undefined slopes. And it's the same idea or same concept when there is a 0 slope. Except this time, it's with the y. Very good, Hassan. This time, it's with the y because with our 0 slope, you are creating a horizontal flat line at a very specific point for y, but an infinite value for x. X is every number. Y is the only number that's very specific. So this would be set up as y equals whatever your y1 coordinate is. So 0 slope, my point is 5, 9. Then my equation is y equals 9. If my point is -6, 7, what's my equation? Y equals 7. What about for number 3?
Y equals -3.
And then number 4?
Y equals -1.
That simple. Those special criteria for undefined and 0 slopes, that's what those equations look like. You have a quizzes loaded into Google Classroom.